We are going to learn about how to use trigonometry to solve for an angle and sides of a right triangle. So let's say we have a right triangle, and we will label this angle theta. The leg of the triangle that is opposite theta is called opposite. The leg of the triangle that is next to angle theta is called adjacent, and the hypotenuse of the triangle is just called hypotenuse. So if I have a right triangle like this will be opposite, since this is the side that is opposite theta. This will be adjacent, since it is next to theta, and this will be the hypotenuse. The hypotenuse is always opposite the right angle. The opposite and adjacent leg all depends on where theta is. Now, we are going to learn about three main trigonometric functions. These are sine, cosine, and tangent. And sine theta is equal to opposite over hypotenuse. Cosine theta is equal to adjacent over hypotenuse. And tangent theta, which we can write as tan theta, equals opposite over adjacent. And in this video, we are going to use these trigonometric functions to solve for the sides and angle of a right triangle. If you are a bit confused right now, let's do some practice problems. Let's say we have this right triangle. What is sine theta, cosine theta, and tan theta? Well, sine theta equals opposite over hypotenuse. So if we look at this picture, the side opposite theta is 5, and the hypotenuse is 13. So sine theta equals 5 over 13. So what is cosine theta? Cosine theta is adjacent over hypotenuse. We reviewed that the adjacent side is the side that is next to the theta. Therefore, the adjacent side is 12. Since cosine theta is adjacent over hypotenuse, cosine theta is 12 over 13. Now, what is tan theta? Tan theta equals opposite over adjacent. We reviewed that the opposite is 5 and the adjacent is 12. So tan theta equals 5 over 12. Let's try another example. Let's say we have this right triangle. What is sine theta, cosine theta, and tan theta? Well, sine theta equals opposite over hypotenuse. Opposite is the side that is opposite theta. Since 35 is opposite theta and 37 is the hypotenuse, sine theta equals 35 over 37. Now, what is cosine theta? Cosine theta is adjacent over hypotenuse. The adjacent side is the side next to theta. So this is the adjacent side. However, we do not know the value of that side, so we need to find that side. To find a side on a right triangle, we are going to use the Pythagorean theorem. If you do not know what the Pythagorean theorem is, please watch the video Pythagorean theorem, which is linked below. Now, the Pythagorean theorem says c squared equals a squared plus b squared. C is the hypotenuse, and A and B are the two legs. So we get 37 squared equals 35 squared plus B squared. 37 squared is 1,369, and 35 squared is 1,225. So we will get 1,369 equals 1,225 plus B squared. We need to isolate B, so we will get 1,369 minus 1,225 equals B squared. 144 equals B squared. When we take the square root of both sides, we get 12 equals B. The adjacent side is therefore 12. Cosine theta equals 12 over 37. Tan theta equals opposite over adjacent. We reviewed opposite is 35 and adjacent is 12. So tan equals 35 over 12. Let's try another example. Let's say we have this right triangle. What is the value of theta? In other words, this question is asking what is the value of this angle. Now, we are only given two sides of the triangle, and that is okay. If you want, you can find the third side of the triangle. You can find the hypotenuse using the Pythagorean theorem. But in this case, it is not necessary. So we have this triangle. And what is 15 in this case? Is 15 the opposite or is it the adjacent? Since 15 is opposite theta, 15 is the opposite. Now what is 8? Since 8 is next to theta, 8 is the adjacent. So let's see what we have. We have the opposite and we have the adjacent. Therefore, let's use tan, since tan equals opposite over adjacent. So we get tan theta equals 15 over 8. Now, we have to isolate theta. How do we do that? The answer is that we have to take inverse tan. So we will do inverse tan on this side and inverse tan on this side. This makes the inverse tan and the tan cancel, so you are left with theta equals inverse tan of 15 over 8. Now, what does inverse tan of 15 over 8 equal? We will need a calculator for this. So I have the Desmos calculator out, and I will do inverse tan of 15 over 8. This is equal to 61.93 degrees, which we can round to 62 degrees. Therefore, this angle is 62 degrees. Let's try another example. Let's say we have this right triangle. What is the value of theta? In other words, this question is asking what is the value of this angle. Now, we are only given two sides of the triangle, and that is okay. If you want, you can find the third side of the triangle. You can find the other leg of the triangle using the Pythagorean theorem. But in this case, it is not necessary. So we have this triangle. And what is 9 in this case? Is 9 the opposite or is it the adjacent? Since 9 is opposite theta, 9 is the opposite. 41 is the hypotenuse since it is opposite the right angle. So let's see what we have. We have the opposite and we have the hypotenuse. Therefore, let's use sine, since sine equals opposite over hypotenuse. So we get sine theta equals 9 over 41. Now, we have to isolate theta. So we take inverse sine. We get theta equals inverse sine of 9 over 41. So we take our calculators out and we plug that in. We then get 12.68 degrees, which we can round to 13 degrees. Therefore, this angle is 13 degrees. Theta equals 13 degrees. Now, let's try finding the angle if we used a different trigonometric function. What if we used cosine? Will we still get the same answer for the angle? So cosine is adjacent over hypotenuse. This is the adjacent side, since it is next to angle theta. Since we do not know the adjacent side, let's use the Pythagorean theorem. The Pythagorean theorem is c squared equals a squared plus b squared, where c is the hypotenuse and a and b are the legs. So we get 41 squared equals 9 squared plus b squared. We then get 1681 equals 81 plus b squared. We then get 1600 equals b squared. And when we square root both sides, we get 40 equals b. This side is therefore 40. So we figured out the adjacent side is 40. Since cosine is adjacent over hypotenuse, cosine theta equals 40 over 41. Now let's solve for theta. So we take inverse cosine of both sides. We then get theta equals inverse cosine of 40 over 41. When we plug that in the calculator, we get 12.68 degrees, which we can round to 13 degrees. This is the same answer we got with sine theta. It does not matter which trigonometric function you use, as long as you have enough information for that function and you are using it correctly.